Well, this is fun. I'm going to do another one. Let's say that you start over here. I'm going to make this 0 meters. But you don't start there. You start over here at 0 seconds. And then you're speeding up from 0 meters per second. So here you are at 0 seconds. Then there you are at 1 second. There you are at 2 seconds. There you are at 3 seconds. Forget it. I'm going to make this 0 meters. Sorry about that. Remember that to the right is positive. At first you're not moving. And now you're moving here at 3 meters per second to the left. And to the left is negative. And that would be negative 3 meters per second. Why is to the left negative? Because I just felt like it today. I could have made it positive, but I already made to the right positive in the previous examples, and I need to be consistent. If that's negative 3 and we're 0 to negative 3, that's a change in velocity of negative 3 meters per second in that 1 second. And we're dealing with uniform or constant acceleration, which means that my velocity will change by the same amount in the next second to go from negative 3 and change by another negative 3. This is negative 6 meters per second. And then this one, to go from negative 6 and change by negative 3 would be negative 9 meters per second. Okay, so now are we getting faster or slower? We're getting faster. Remember the number, not the sign, the number represents the speed. We say that speed is the magnitude of velocity, how fast we're going. The sign represents the fact that we're going to the left. We're going from 0 to 3 to 6 to 9 meters per second to the left. All right, the negative sign represents that. Now I'm not going to start it here at 0 meters because that 0 meters, at 3 seconds I'm at 0 meters. I start out up here because I start out, if that's 0 meters, I start to the right of it. There's to the right, and to the right's positive. So I start positive. I'm going to end up at 3 seconds back here. But I'm getting faster. And the faster you go, the steeper the position time graph. It's going to look something like this. We're just sketching it. I kind of missed. Try it again. Okay. Close enough for government work. Okay. So there we go. It gets steeper. It starts out flat, which means 0. 0 velocity. Or slope is 0. Slope of this represents the velocity. Right? It's steeper, it's steeper, steeper, steeper. At 1 second, let's say 1 second is about right here. That would mean that the slope is negative 3. At 2 seconds, the slope would be negative 6. At 3 seconds, the slope would be negative 9. Okay? And then you would plot that over here. At 0 seconds, the slope is 0. It stopped originally. At 1 second, the velocity is negative 3. Be here somewhere. All right? Negative 3. Negative's down here. Positive's up there. Negative 3. At 2 seconds, is traveling at negative 6, which would be now, if that's negative 3, that must be negative 6 down here somewhere. All right? And then at 3 seconds, it's at negative 9, which would be down here somewhere. Okay, I'm looking down on the y-axis here for a velocity graph. All right? Negative 9 right around there at 3 seconds, somewhere like that. It's linear. And what's the slope of this? Well, the slope of that, if that's negative 9 and that's 3, rise over run, well, this isn't a rise, it's the exact opposite, but still, that goes from 0 to negative 9. And you know the slope is going to be acceleration. It's going to be from 0 to negative 9 is negative 9 over 3 seconds is negative 3 meters per second squared. That would be down here somewhere, negative 3, and that would be constant negative 3. Now here's where you say to yourself, self, hold on, stop, hold the phone. That's negative 3, but you're getting faster. Compare that to the previous example where you were traveling. The previous example, you're traveling to the right and getting slower. What was the acceleration in that one? It was negative 3 also. So negative acceleration does not necessarily represent slowing down. Notice that. Negative 3 meters per second, you're speeding up. Acceleration is a vector. Velocity is a vector. Okay, be careful. I can give you a quick example of a situation where that's pretty common. If I make up positive and down negative, the acceleration in this classroom is roughly negative 10 meters per second every second, roughly negative 10 meters per second squared. When this is in the air, after it leaves my hand, it's traveling upwards, positive direction, but slowing down. It's an acceleration of about negative 10 meters per second. It's like the previous example, where it's moving in the positive direction and slowing down. That was negative 3 meters per second squared in the previous example. In this example with the whiteboard marker in my classroom, in the air, it's about negative 10. And then on the second half of the journey, it's coming down the negative direction. Down is negative, up is positive. Negative direction and speeding up. But it has the same acceleration, right? Because the gravity is the same. And gravity is what causes the acceleration on this whiteboard marker in the air. Gravity is the same. It hasn't changed direction. Gravity causes the acceleration. It causes the whiteboard marker to slow down on the way up. It causes the whiteboard marker to speed up on the way down, and that hasn't changed. Okay? So, be very, very careful. Okay. And then the last example, I'm going to just speed through this, is one that is traveling to the left. Again, I'll make 0 meters over here somewhere. It's traveling to the left and slowing down. So that's at 0 seconds. And we'll make that negative 9. That'll be negative 6 at 1 second. That'll be negative 3 at 2 seconds. And then it'll be stopped. Okay, and we'll also make that 0 meters just like last time. So what does that look like? Well, at 0 seconds, it's up here. At 3 seconds, it's 3 seconds. It's at, there's 3 seconds. 0, 1, 2, 3 seconds. It's stopped. So it's going to end up at the same spot, 0 meters at 3 seconds, 0 meters at 3 seconds, right here. Starts at the same place. Okay, at 0 seconds, it's way over to the right. Right is positive. But it's getting slower, and slower is leveling off. Okay, and these are this has to have a negative slope because these are negative velocities. Negative slope is pointed downwards. It's going to look something like this. Okay, it's going to look something like that. At 0 seconds, it's traveling at negative 9. At 0 seconds, 0 seconds, it's traveling at negative 9 meters per second. Right here. By the time you get to 3 seconds, it's stopped. Stopped is right here. There's that graph. And the slope of this, how do you go from negative 9 to 0 in 3 seconds? You add 9. The change in velocity, the acceleration, change in velocity is positive 9 over 3 seconds. All right? Because it goes from negative 9 to 0 in 3 seconds. So you have to, how do you go from negative 9 to 0? You add 9. That's the change in velocity. All right? So that is positive 3 meters per second squared. Plus 3 is up here somewhere. That would be your, should be horizontal. That would be your acceleration time graph. Okay, really quickly. Notice this is slowing down with positive acceleration. It's slowing down with positive acceleration. Whew. Okay, you have to be careful. Look at the examples. I've given you 4 examples. Notice that when you have when an object is speeding up, that would be the very first example, and the one just before this, the first and third example. And both of those are objects that are speeding up. Whenever an object speeds up, the velocity and the acceleration have the same sign. In the first example, the velocity was positive. It was an object speeding up to the right. Velocity was positive, and the acceleration was positive. All right, you went from 0.369 meters per second, acceleration of positive 3 meters per second squared. In the previous example to this one, you are speeding up to the left. You went from 0 to negative 3 to negative 6 to negative 9 meters per second, and the acceleration was negative 3. Right? So when you're speeding up, the velocity and acceleration have the same sign. Notice that in examples 2 and 4, this is the 4th one, the velocity and acceleration are opposite. And that's always going to be the case when an object is slowing down. Okay? You are slowing down in the negative direction. Negative velocities, negative 9, negative 6, negative 3, positive acceleration. Okay. In example 2, you were slowing down in the positive direction, you had negative acceleration. Okay, slowing down, opposite signs for velocity and acceleration. Speeding up, same sign. Bye.